Hello students, in the previous video we discussed some of the properties of for discrete time Fourier transform, and we also took an example on that as well, and plot the magnitude spectrum for that. Now here it's a different kind of problem here. So given a signal x of n, so 1 3 5 3 1, that means it's a discrete time signal with amplitude mentioned 1 3 5 3 1, where the origin is at 5. So here at 5, this is the origin, that means at origin the amplitude is 5, and the problem also continues that after finding x of e power j omega, so that is the dtft of x of n, we should also evaluate for omega is equal to 0. That means we have to substitute omega is equal to 0, and we have to get the result for that as well. Okay, now let's start solving this. So from the definition of Fourier transform, we have x of e power j omega is equal to x of n e to the power of minus j omega n, where n varying from minus infinity to plus infinity. Now if you look at this signal, here we have the origin 0, so that means, so to the right we have 2 samples and to the left we have 2 samples, so the signal varies from minus 2 to plus 2. So our limit will also be from n is equal to minus 2 to plus 2 x of n e power minus j omega n here. Now we have to elaborate this expansion by applying the values to n starting from minus 2 to plus 2. That means 5 values we have to substitute here. So let's elaborate. X of minus 2 e power minus j, minus into minus become plus j 2 omega, plus x of minus 1 e power j 1 into omega is omega itself, plus x of 0 e to the power of 0, plus x of 1 e power minus j omega, plus x of 2 e power minus j 2 omega. Now we have x of minus 2, minus 1, 0, x of 1 and x of 2, whose values are already given here. So this is x of 1, x of minus 2, minus 1, 0, x of 1 and x of 2. So let's substitute these values here. So x of minus 2 is 1. So 1 into e power j 2 omega, plus x of minus 1 is 3. 3 into e power j omega, plus x of 0 is 5, and e to the power of 0 is 1. So that's why 5 only here, plus x of 1 is again 3 e power minus j omega, plus 1 into e power minus j 2 omega. Okay, so now if you look this, we have e power j 2 omega, e power minus j 2 omega, and here we have 1 and 1. If you add that, it will get 2, and e power j 2 omega, you can write it as cos 2 omega, because why I am writing like this, because we have the relation like cos theta is equal to e power j theta plus e power minus j theta divided by 2. So that gives us 2 cos theta is equal to e power j theta plus e power minus j theta. So based on this, we can write it like this. Same thing, we can do this for another one. Here we have 3 into e power j omega, 3 into e power minus j omega. So that means if you multiply 3 into 2, that becomes 6, and this becomes cos omega, and these two if you combine, that becomes 2 cos 2 omega, and we left with 5 alone here. So this is what we are applying here. So therefore our x of e power j omega will become 2 into cos 2 omega. So based on this, plus 3 into 2. So I'll write that step, 2 into 3 cos omega plus 5. Okay. Now if you simplify this, we'll get, I'll write the constant on 5 plus 3 into 2 6 cos omega plus 2 cos 2 omega. So this is x of e power j omega. Okay. Now we should find the value at omega is equal to 0. That means what is the value of x of e power j omega at omega is equal to 0. Now x of e power j omega becomes at omega is equal to 0, 5 plus 6 cos 0 plus 2 cos 2 into 0. Okay. So that gives us 5 plus cos 0 is 1 here. So 6 into 1 plus cos 0 again 1, 2 into 1. So 5 plus 6 plus 2, that gives us 13. So this is the answer for x of e power j omega at omega is equal to 0. Okay. So we'll move on to the next one. So here the problem is given like this. Evaluate dtft of the signal. So given x of n is equal to delta 6 minus 3 n, and the problem continues. Sketch the magnitude and phase spectra. Okay. Now for this kind of problem, we have to, given signal is x of n, so we have to find x of e power j omega. So now x of e power j omega is equal to summation n varying from minus infinity to plus infinity x of n e power minus j omega n here. Now if you substitute x of n, so that is delta 6 minus 3n e power minus j omega n here. Now from the definition it says delta n is 1 only at n is equal to 0, and it is 0 at n not equal to 0. So given signal is delta 6 minus 3n. So this signal will be 1 for 6 minus 3n is equal to 0, and it will be 0 for 6 minus 3n not equal to 0. So we are not concerned about this 0 part, we are only concerned with this part where the signal exists. So if you simplify this, so you'll get minus 3n is equal to minus 6. So n is equal to 6 by 3, that is 2. So n is equal to 2 here. That means delta 6 minus 3n is 1 at n is equal to 2 only. So that is the meaning of this. So that means the signal exists only at n is equal to 2, and in the remaining part it will be 0. So the signal is from minus infinity to plus infinity, but the signal exists only at n is equal to 2. So this allows us to write the expression like this: e power j omega is equal to delta 2 e power minus j 2 omega. Now delta 2 value is 1 because based on the definition of that. So we will end up with e power minus j 2 omega. Okay. So now this is the some of these are the standard derivations for DTFT. The same one that we solved in the previous example, where we got x of n is equal to alpha n into u of n. So that alpha can take any alphabetical value, sorry, not alphabetical, like any constant values like 2 to the power of n into u of n, or 1 by 2 to the power of n into u of n. So these kind of signals are the standard derivatives. So this will be useful while applying the property. So we have to remember this. Now since it is delta present at 2, we get e power minus j to omega. If we have delta n alone, then you will get e power j omega n here. Okay. So that is the standard. That means if you perform DTFT for this signal, you will get x of e power j omega as e power minus j omega n. So this is the standard derivative for that. If you take delta 2, then it will become e power minus j 2 omega. If you take n is equal to 1, it will be e power minus j omega, and so on. Okay. So this is just for your additional information, so to remember. Okay. Now continuing with the problem, we have to find the magnitude and phase spectra here, and which will be drawn for one particular duration, that is plus minus pi to plus pi. So magnitude spectrum. Now here if you look at the signal, we have e power minus j to omega, that is x of e power j omega. You have to take the mod. So that is e power minus j to omega. If you simplify this, you will get cos 2 omega minus j sin 2 omega. Now since we don't know what is the value of omega, we can't conclude it. Now if you take the plot here, x of e power j omega. Okay. Now here it is 0, pi and minus pi. So obviously we are looking at what will be the value here. Now based on this, if you want x of e power j omega, since we have not sorted it out here, cos 2 omega minus j sin 2 omega. If you look at this, if you want the value at 0, omega is equal to 0, so x of e power j omega, so you will get cos 0 minus j sin 0, which is sin 0 is 0, so cos 0 is 1, you will get 1 here. Now if you go with omega is equal to plus pi, x of e power j omega, so you will get cos pi, I think cos 2 pi here, because we have 2 omega, that's why. So we'll get cos 2 pi minus j sin 2 pi. Sin 2 pi is 0, again cos 2 pi is 1, so you'll get 1 here. And if you go with minus pi, I think it won't change much here. You will get the same here, cos minus 2 pi cos minus 2 pi minus j sin minus 2 pi. Again you will end up with 1 here if you take the mod for this. So that means we can conclude that the value x of e power j omega is 1 for the entire duration. So that means it will go on. If you go with pi, 2 pi, 3 pi, 4 pi, and here minus 2 pi, minus 3 pi, it will remain same only. So that's why we can write it like this. We have a constant amplitude 1 at 0 and at pi and at minus pi. So this will keep on continuing if you go further. Okay, so this is the magnitude of the signal. Now coming to the phase. phase spectrum, so we had x of e power j omega. So we got e power minus j 2 omega here. So based on this, we can take, if you simplify this, cos 2 omega minus j sin 2 omega. Now if you want to take the phase of phase, that is tan inverse of b by a, so b is minus sin 2 pi divided by cos 2 pi. Now this sin by cos, we can write it as tan inverse of minus tan 2 pi. So we have tan inverse and tan here, which get cancelled, these two. So we will remain with minus 2 pi. So that means the value of phase x of e power j omega is equal to minus 2 pi. Now if you come to the plot here, phase of x of e power j omega, so we have to plot the same duration from minus pi to plus pi by applying the values for this. Okay, I think I made a small mistake here. This is not 2 pi, this is omega, so that means I have to change this, all these values. We'll end up with 2 omega, 2 omega, 2 omega, and 2 omega. If it is pi, we could have simply substitute the value here. So this is minus 2 omega. So now if you observe, we have to apply the values for omega at 0. 2 into 0, we will get 0 itself. Now at pi, if you substitute plus pi for this, minus 2 into pi, so that is minus 2 pi somewhere here. So here I'll put a point here, this amplitude is minus 2 pi, and if you come to this point here, minus pi is there. So minus 2 omega, that is minus 2 into minus pi gives you plus 2 pi. So that is somewhere here, plus 2 pi. So at minus pi, the amplitude is plus 2 pi, and at plus pi, the value is minus 2 pi, and at 0, it is 0. Now if we join this line, so you will get something like this here. Okay. Now this is the phase of the signal. Okay. So hope you got this. Okay. So it depends on the problem and what is the result you got, how to plot the magnitude and phase spectra here. Okay. Let's move on to the next problem. So given, find the DTFT of a signal x of n is equal to a to the power of magnitude n, a is less than 1. So only this much is given. We have to find x of e power j omega, and we have to, no need to plot magnitude or phase spectra. So this looks simple, but you have to be careful while taking the limit here. So x of e power j omega is equal to summation n varying from minus infinity to plus infinity x of n e power minus j omega n. Now let's substitute the value of x of n here. It is n is equal to minus infinity to plus infinity a to the power of magnitude n or mod n. So the meaning is n here can take the positive value as well as negative value. Okay. Now if it takes positive value, then what happens to the signal, and if it takes negative value, then what happens to the signal? That what we have to find out here. Let's do that. So we have to consider both the positive and negative axis here. Now if n is negative, then the negative values will be from minus infinity to minus 1, and after that, that is 0 and above, that means 0 to infinity, the values of n will be considered as positive. Okay. Now we have to split this. If you take the negative value, then n varying from minus infinity to minus 1, a to the power of minus n, e to the power of j omega n here. Okay. Next, j power minus j omega n. Next, plus summation n is equal to 0 to infinity a to the power of n e power minus j omega n. So this is kept as it is, alias applied only for n, we have not yet substituted. Now here if you observe this, we have a limit varying from minus infinity to minus 1. So if you change this from n is equal to 1 to infinity, 1 to infinity means the sign of this n will be reversed. So that means it will be a to the power of plus n, and here we have one more n, so that should also change to plus n. So e power j omega n plus summation n is equal to, so this is no change here, a to the power of n e power minus j omega n. Now n is common in both of them, so we can combine this like this, a into e to the power of j omega n plus summation n is equal to 0 to infinity a e power j omega, that is minus j omega to the power of n. Okay. Now this is what we end up here. Now if you observe the geometric series, so if you have something like n is equal to 0 to infinity a to the power of n, so this can be written as 1 divided by 1 minus a. Similarly, if you have something with limit 1 to infinity, same thing, then it will be a divided by 1 minus a. If it is 2 to infinity, then it will be a square divided by 1 minus a, and so on. So it will go on like this. Now we are going to apply these two for the above expression. Based on that, we will get for the first one, it is a by 1 by a. In place of a, we have a into e power j omega. So a into e power j omega divided by 1 minus a into e power j omega plus, here it is 0 to infinity. So that means 1 divided by 1 minus a into e power minus j omega. Okay. If you go for further simplification, you can take the LCM for that, 1 minus a e power minus j omega. So if you take LCM, so you will get a into e power j omega 1 minus a into e power j omega, sorry, minus j omega here, plus 1 minus a into e power j omega. Now if you multiply this, you will get a e power j omega minus into a square e power j omega e power minus j omega plus 1 minus a into e power j omega divided by 1 minus a e power j omega, or you can directly simplify the below one by multiplying that as well. So which you will end up with 1 minus a e power minus j omega, sorry, plus, not minus here, minus a into e power j omega plus a square e power j omega e power minus j omega. Now these two terms here, so they will get they become 1 here, plus and minus will get cancelled, and based on that we can write a e power j omega minus a square plus 1 minus a e power j omega. So this is the numerator. So coming to the denominator, so this term becomes 1. So we'll end up with 1. So these two are common terms, minus and minus. So that becomes minus 2a e power j omega plus a square. And here you can see these two we can get cancelled here. So we remain with minus a square plus 1. So if you rewrite that, 1 minus a square divided by 1 minus 2a e power j omega plus a square, or you can rearrange this like 1 plus a square minus 2 into a power j omega. That will be the final answer for this one. Okay. So moving on to the next kind of problem here. So I'll take a different one. So what is the problem given? Find the time domain signal corresponding to the DTFT shown in the figure. So here the plot is given. Now using this plot we have to find, that means we have to reverse it. X of e power j omega is given. The signal is like this. And the same signal look like this here. So here minus pi, minus 2 pi, minus 3 pi and 0. So this part of the signal is called e power minus omega, and this one is e power omega. So this is a increasing exponential and this one is a decreasing exponential. So from this we have to find the time domain signal. Time domain signal means, so if x of e power j omega is given, so the time domain signal of that will be x of n. So it's a reverse process. So for that we have to use the analysis equation. Now let's find out what we have from the figure. So from the figure, let's define this. E of x of e power j omega is e power omega from, for the duration, minus pi to 0, and the value of x of e power j omega is e to the power of minus omega varying from 0 to pi. So now this is the signal we have from the diagram. We define this. Now the limits differs from minus pi to 0 and 0 to pi. Two different limits we have to deal with. So let's start with this. X of n is equal to, so this is what we have to find, the time domain signal, 1 by 2 pi integral of, so you can take limit from 0 to 2 pi or from minus pi to plus pi, x of e power j omega n d omega. Now let's apply the limit for this. So x of e j omega, we have two different limits. So we are going to split the integral limits here. So integral of minus pi to 0 x of e power j omega into, okay, I will just write it down here itself, x of e power j omega, the value is e omega e power j omega n d omega plus integral of 0 to pi e power minus omega e power j omega n d omega. So if you move further, we have the limit from minus pi to 0 and we have common base here. Let's combine the signal since we have common base. So this becomes e to the power of j omega, so omega plus j omega n d omega, and here this becomes e to the power of minus omega plus j omega n d omega. Okay, so if you move further, you can go for one more simplification. That means you can take omega out here. So that leaves with 1 plus j n omega plus 0 to pi e to the power of 1, or you can write it like j, yes, jn minus 1 omega d omega. So next step, if you integrate this, 1 by 2 pi e to the power of jn plus 1 omega divided by jn plus 1, and the limit is from minus pi to 0 plus this one is e to the power of jn minus 1 divided by jn minus 1, limit is from 0 to pi. Now I'm not going to go for the entire simplification. Now if you apply the limit and simplify, okay, so you should end up with okay, I'll do this one more step, 1 by 2 pi, so you'll get e to the power of 0 minus e to the power of minus jn plus 1 into omega divided by jn plus 1, plus if you apply limit for this one, you will get e to the power of jn, I think omega is left over here, jn minus 1 pi minus e to the power of 0 divided by jn minus 1. Now if you go further simplification, you should end up with 1 plus, that means you have to convert this exponential, this will become 1 and 1, you have to convert this into exponential, sorry, a trigonometric form, and you have to apply the limit. So my value pi here, if you simplify that, so you should get this answer. Okay, so another 1 or 2 step, you will end up with this as the result. X of n is equal to 1 plus minus 1 to the power of n divided by pi n square plus 1. Okay. Now based on the same method, I want you to try some other problems as well. So this is just for you to try some problems. So first one, I'm giving you x of n is equal to alpha n sine omega naught n. So this is just to differentiate with the omega we have in the expression. So for this you have to find the DTFT of the signal x of e power j omega. So this is one problem, and try this as well. So just to given x of n is equal to 2 to the power of n into u of minus n. So this is similar to the first problem that we have discussed in the last video, where in place of 2 we had something like alpha n into u of n. So this is the same steps you have to find, and no need to plot magnitude or phase spectra for this one. This just you have to find the values as well for that, and try this one as well. Given x of n is equal to delta n, and here for this draw its spectrum. That means you have to plot not magnitude or phase spectra, you have to just plot x of e power j omega. Okay, so you have to plot only this from minus pi to plus pi. So that is what you have to do, delta n. Okay, so try this problem. Okay, and one more thing, just wanted you to solve this as well. So the problem goes like this here. Given x of e power j omega, given x of e power j omega is equal to cos square omega. So this one you have to solve. That means you have to find out x of n here. Okay, so the one that I solved before. So you have to go for that process to get x of n, the reverse order. Using the analysis equation, you have to find the signal x of n here. Okay, anyhow, I will mention that as well. Find x of n for the fourth one. So try these problems on your own, and try to get the solution for this. Okay, so that's it for this video. In the next video, I will take some other examples on DTFT, which might be applying the properties of DTFT, how to get the solution. So that kind of problems we will take in the next video. So thank you for your time, and if you have any queries, do comment or reply to the video. Thank you.